Okay, can people in the back hear me? Are we good? Awesome. All right, so again, that was a great lecture on how images work, right? We have three alternatives on storing images, but we're going to be using a cloud-based service, which is much more secure than anything we're probably going to build by ourselves or as app dev groups or hack challenge groups. So I just want to quickly demonstrate what we're going to be building today. Here's a service that converts an image to base 64 strings. So what this means is it kind of encodes your image into a string, and sending this across the network and like in through a request is a better alternative than just sending the file directly. So we're first going to be doing that, sending a request to AWS, and then AWS will give us the URL, and we'll take a look at that URL to see if it was actually uploaded to our server correctly. So in my Finder, I have a file that I am going to be using today. This is me playing baseball when I was like 4 years old. Okay, not actually, 4th grade or something. So we're going to be converting this into a base 64 string. Oops, that's my CB homework. So let's drag this in here. And you can see that this image actually got encoded into a base 64 string. So instead of passing in a file, right, because how would you do that here? We're going to be passing in a string. And that string, again, can be accessed through this URL, if you guys want to take a look at that. So I'm just going to go kind of click copy image. Sorry if that's a little hard to see. There's a button right here called copy image. And if I paste this, it's going to be a huge string that basically has every information about the image I just uploaded. Obviously very, very long. And we're going to be sending this to the server, which will then return us a link to that image. So if I actually copy this and paste this into my browser, you can see that an image is downloading. And if I click here, I can once again see that image. So this is what your front end is essentially going to be doing. Your front end developers are going to be sending a request to your backend. The backend will return the URL, and then the front end will then kind of download that file and store display it on their front end. So that's how images is going to work today. So how do we go about doing this? Well, obviously, we have to be using a cloud-based service called AWS. So let's first go to AWS, just look up AWS, and then it'll be the first link. Also, forgot to mention, the starter code is on the textbook. So if you just go ahead and go to images and then demo, the starter code's right here. Cool. So now that we're on the AWS website, hopefully this is what everyone sees. We can sign into the console. And I already have an account, but for those of you who don't, maybe we can spend like a 3-ish minutes setting that up. So you can just click on create new AWS account and use your Cornell email as I am doing. Okay, CAPTCHA. Okay, who here is trying to follow along demo today? Okay, and all right, we can give everyone a couple of minutes to set this up then. In the meantime, I will open the starter code on my VS Code. Okay, I hope the majority of you were able to sign up. I'm just going to go ahead and get started. If you are still making your account, just ask a neighbor on what I did so far, and then hopefully they can get you caught up. So now that we're logged into our AWS Management Console, the button we have to click is under Services. Once you click on Services, you scroll down. There is a tab that says Storage at the very, very bottom. We click that, and then we click on S3. So like Maria mentioned, we're going to be storing our images on Amazon S3, which are kind of like containers for all of our blob-like files. And this is a bucket that actually is currently holding the picture of me playing baseball from a while ago. But we're just going to go ahead and make a new one just to demonstrate this to you all. So, hey guys, for those of you who are asynchronously watching this, I set up my bucket wrong during demo. So the way you're supposed to do it is when you create the bucket, we'll just call this the same thing I called it in demo. What did I call it again? And then we'll set the region to be USD Swan. The ownership, this is the part I missed. You have to enable ACLs. So this essentially allows our code, right, which isn't exactly our AWS like root account, to edit the permissions on each file that's in our bucket. So yeah, just make sure you turn this on, which I didn't do during demo. And then same thing here, you can turn off all, or you can turn on all public access, acknowledge that you're being dumb, and then and then create the bucket. Okay, so that's the only fix. I will make sure to edit the demo so that this change is reflected. So now we have a newly created bucket called images demo Shungo that is publicly accessible. Cool. Is that good so far? Good. All right. Next, we need to have a way of accessing this bucket. Now, there's several layers of security on kind of accessing service like AWS or Google Cloud, et cetera, et cetera. And that layer of security for AWS is going to be secrets. So we need credentials to be able to access this images or this bucket, because otherwise, literally anyone in the world can access this bucket, right? And we don't want that. So the way we can make a set of credentials is to click on my username on the top right and hit security credentials. And then we can go to access keys and create an access key. Now, I'm just going to go ahead and click create a new access key, and I'll show what my values are. These values are secret values. We do not want to ever be sharing this on the internet or uploading it to app.dev YouTube channels, which is what I'm doing today. But I'm going to be deleting this immediately after demo because I don't want people accessing my AWS services. Now, question for the audience: where do we want to be storing these values? Hands. It's in a file. It's in a specific file. Yes. Exactly. Thank you. We want to be storing these values in the .env file, right? Environment variables file, so that we don't have people externally being able to see these values. So with the starter code open, I'm going to create a .env file. And we're going to have 3 keys for it. One of them we're going to call S3 bucket name. This is so that, for us to be able to access our bucket, we need to know the name of the bucket. And there's literally no reason for us to be publicly sharing that, right? Like, why do we need our users to know what the name of the bucket is? So we'll make that a secret value as well. So I called it images-demo/shingo. And then the next 2 are the 2 values that I generated from the credentials management screen. So the access key ID and the secret access key. The key name for both of these values is AWS_access key_ID. And the next one is AWS_secret_access_key. Also, I just realized I forgot to turn on my video, so I'm going to do that. Okay. I start recording this? Okay, I did. Awesome. Okay. So hopefully you have these two copied down now, and we can go ahead and paste this into the access key, and paste that into our secret access key. And again, we don't want to be sharing this to the web, right? So we have to make a dockerignore file and add a .env file here. I think a good number of people missed points on the deployment assignment because they forgot to include the .env file in their dockerignore. But once again, we never ever want to be pushing our .env file to GitHub, Docker, or any online services. So let's make sure we have that. And then in our dockerignore file, we also need to add a couple other things. The first one is our virtual environment. The next one is our PyCache. And then the last one is our database file. Now, the database file is going to be defined in our app.py. So this has been the case since, I think, demo/programming assignment 2. But it's defined right here. So make sure you dockerignore this file specifically. I think a number of submissions also were like, they dockerignore todo.db, which is the one we use in demo, as opposed to cms.db, which is the one that was actually in the assignment. So make sure you're docker-ignoring the right .db file. Cool. Awesome. With that done, let's create our virtual environment. So the requirements.txt this time around is pretty big compared to previous demos. So I'm going to go ahead and make a virtual environment and install all of these dependencies. Okay, and then we can do .env wait and install. All right, while we wait for this to happen, let's kind of go through what our code actually has, like our starter code has right now. All right, so we have our app.py. We have our generalized success and failure responses. We have a hello world endpoint, and we have an upload endpoint, and that's it. So this is actually the only endpoint we're going to be implementing this week, right? All we want to demonstrate is how we can upload images to the web. So this is the endpoint we're going to be using. And then in our db.py, we basically have nothing. This we will be coding up from scratch. Okay, so let's activate my, oops, already activate my virtual environment. Okay, awesome. So now that's done, we can start coding. Fun. All right, so we're gonna have to do a lot of importing libraries. So yeah, this is gonna be kind of busy work, but we have to import base64. We have to import Bodo3. We have to import datetime. We have to import IO. From IO, we have to import bytes IO. We have to, from MIME types, import guess extension and guess type. I already wrote a couple of them down, so let's just go over what each of these are going to be used for. So base64 is obviously going to be a way for us to be able to understand what's being sent from the front end, right? The base64 file or string. Bodo3 is our library for accessing AWS. Datetime is to get the current time, right? If you look at the response body I got from uploading this, I have a field that was like, when did it get created? So that's what the datetime is for. This is input output. You don't have to worry about this too much. This guess extension thing is going to be pretty important. So if we want to support, say, like only PNG files or only JPG files, then this guess extension thing, function, will be able to guess the type of the file when we just send it in as a base64 string. Okay, hopefully most of you got a lot of these copied down, so I'm going to move on. We have to import OS, right? This is for accessing environment variables. Import image. Don't worry about this too much. We have to create an image object when trying to upload it to AWS. Random is for creating a random name for our file. So if you noticed, the file that was actually generated has a very random string as the file name. This is because we don't actually want to be storing any sort of user information in the in these file names in the case they get compromised, right? It doesn't really matter what these are called, so it's just going to be a random string. So that's what random is for. We're going to be importing RE, which I don't actually know what it does, and then string, which is for cool string manipulations that we can do in Python. Cool. So with all these imports out of the way, let's define a few constants. So the first one is what extensions we're going to be accepting. Let's accept PNG files. Maybe we'll accept GIF files, JPG, and JPEG. So these are extensions we're going to be accepting. The base directory is going to be os.getcwd. So this is basically doing the same thing as pwd, which I've demonstrated several times, but it just prints your working directory. And the reason why we need this is because for us to be able to access files within our code, we have to give our Python code the absolute path to that file. So that's why we need this base directory constant. We need the S3 bucket name. So this can just be loaded from my environment variables. Right? We defined that right here, right? S3 bucket name. And then the last constant is the base URL. So this is just something that AWS has defined for us, but the link we're going to be using is going to be in this format. It's going to be https://s3 buckets name .s3.us east 1, which is the region I'm actually in my AWS console. If your region is different, it might be a little tricky to do this. So if you look at my URL right here, it might be hard to see, but it says US East 1 on the top. And then .amazon.aws.com. So that's the URL we're going to be pushing all of our images to. By the way, this string format, I think Kate mentioned last time, but in case you didn't catch it, for those of you who haven't taken 1110, this is called, or I don't actually know what it's called, but F strings. You can kind of insert variables within your strings just by wrapping them in curly braces, as long as you have an F preceding the string declaration. So for last demo, I was actually supposed to do hello and then like os.environ.get name as an F string, as opposed to doing hello and then like a plus and then the thing I did. This is better Python practices, but yeah, hopefully just keep that in mind. Okay. Now we're going to be making a model for our images. The model name is going to be asset. And this is a db.model. So we call lecture 4 for this. And we'll just say that this is an asset model. Hopefully this doesn't give you flashbacks, because it was notoriously the hardest assignment probably this semester. But the table name is going to be assets. We have an ID field, which is db.column, db.integer, primary key equals true, auto increment equals also true. And then we have a base URL, db.column, db.string. This is going to be the base URL of our image. So that's this bit right here in the URL. It's the HTTPS demo8 bucket, blah, 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 blah. Like all this is always going to be the same, so we want to be storing it in a variable. And then we have salt, which is our way of making randomized image names. We covered this last time in authentication. we have an extension, which is saying, is it like a .png, .jpg, whatever. We have the width of the image. So if you ever want to use this information during your hack challenge, you can do that too, right? So if it's like over a certain size, you want to display it one way, kind of something like that. Integer null equals false. Also, you can just like copy and paste each of these lines. I'm just typing them out in case people are struggling to catch up, but yeah. And then we have a created at field, which just tells the computer when this file was created. So this is going to be a data type date time, which is actually supported in SQL Alchemy very pleasantly. Yeah, so these are going to be our fields for images. You can see people are still copying this down. So maybe I'll wait a tad bit. Most of these lines are the same, so you can just like copy and paste and change maybe the data type and the variable name. All right, let's move on. So when we create an asset object, we want to initialize it, right? So we need an init function just like we have. We needed one for everything across PA4 and demo4 boards. Initialize this and assets documentation. And when we create a new image model or an asset model, we kind of just want to like go ahead and create that image and like upload it to AWS. So instead of just, like we want to be defining all of these fields, so we'll create a few helper functions on how to on doing that. So the first thing we'll do is creating the image, and we'll just make a new function on creating the image, which will take in self and the image data, which is the image in base 64. And what this create function will do is, given an image in base 64 form, does the following. So it does a few things. The first thing is it rejects the image if it is not a supported file type. It will then generate a random string for the image file name. Thirdly, we will decode the image, and attempts to upload it to AWS. So we'll wrap this all in a try-catch. It's generally nice to wrap things in try-catch if you don't know if it's going to succeed. So something like image upload to AWS is something that's potentially likely to fail. Like if, let's say, AWS goes down, that's not entirely our fault, but it might give us an error, and we don't want our app to crash in case of an error. So we can catch the exception. So what do we put in our try statement? Well, first, right, the first thing we want to do is reject the image if it's not a supported file type. So we can guess the extension of the file that was passed into us by using the guess extension function that was passed in through the MIME types library. We will pass in guess type. So this is just a lot of syntactical stuff. Oops. Oh my God, all my extensions are popping up everywhere. But this is overly verbose. Just write it once and copy it for hack challenge if you like to use images. But this line essentially just takes the extension of the image. So whether it be like PNG, GIF, JPG, or JPEG, that's what this line does. So we will only accept the image if it's a supported file type. So if extension is not in extensions, which is the constant that we defined up here, it's a list of extensions that we defined up here, Then we will raise an exception that will read unsupported file type, and then we will pass in the file type that was unsupported. So make that an F string. Don't forget the F up in front here, and we'll complain that this extension type was not supported. If it was supported, then we want to make a name for the image. So we will here way of generating a random string for image file name. So that's what we want to do, right? Step 2 is to generate a random name for the image. So we will make a salt. This is another case of just copying this code when you want to make the hash challenge. But in short, what this is doing is it's using a combination of uppercase and numerical characters to make our file name. And then once we have a file name with this given salt, we want to decode, right? We want to decode the image and upload it to AWS. So when we pass in a base64 image, there's this image or data image string preceding the image data, and all the way at the very end. Actually, no. Oh, yeah. And then it says data image, and then it says base64 right here. So here's where the image data or like the information about the image actually starts. So we want to cut this part out of the string. So the way we do that is doing header of base64 string. The way we do that is through this thing called regular expressions. You may have heard that kind of buzzword in like CS classes, but you'll learn about it a lot more later if you end up taking higher level CS courses. But this essentially just strips the data image and the base64 part out of your string. It's, again, a bit verbose, but hopefully y'all can kind of deal with it and just like copy it down. So this is saying, I want you to substitute, this is what sub is short for, all this, which is saying data image, any string that starts with data image ends with base64 and everything in between, which is this part right here. And I want you to substitute it with an empty string. So just get rid of it, is what it's saying. Trust me, this part is, I know, again, very kind of confusing. But image upload will be much more fun when we start setting up the bucket and everything. So image data is just, so this is basically, this variable, we wanted to actually store the image and convert it from the base64 form to the actual image form. So the way we do that is by doing base64, which is the library name, and calling the function b64 decode, and then the image string. So this converts it from the string to the actual image as a file. Finally, we will store the file in this variable by converting it from a binary data, which is what this decoding thing does, and storing it as an actual image object, which is understandable by Python. Okay. Cool. Now that we've done that, we want to be setting all of these attributes. So this will be a lot of copy and pasting, but self.base URL is the base URL that we defined as a constant. Self.salt is a salt we just created right here. Self.extension is the extension, right, variable that we extracted up here. Self.width. Now that this img thing is an image object, we can query the width just by doing .width. It's now a parameter within the image object. Self.height, same thing, image.height. We have self.created@. And we can just assume that when we initialize the asset object is when we are creating it. So we'll just do datetime.now. Image file name will be another f string, self.salt.self.extension. So back to this example that I used earlier. The string that was actually used for this file name is this. Right, so a bunch of characters, uppercase, and a bunch of numbers kind of jammed into a string, and then the .png, which is the extension of our file. So that's what this is doing. The salt generated earlier is this part. The extension is this part. So go ahead and copy that if you'd like. And then finally, we will try to upload it to AWS. So we'll make a function called upload and pass in the image object and the image file name so that we'll know how to call it, or like how to name the file when we upload it to AWS. If we catch an exception, we can just print an error. It says error when creating image. We can pass in the error which we've caught as E. Okay, so that is about all we have time for. Next time we will be implementing this upload function and actually calling or creating an asset object in our app.py. But that is images for today. So before we move on to Cahoots, any questions? Okay. Next time I might upload this so that people who don't come today can still partake in Wednesday's demo. But yeah, let's just get started with the Kahoot. So, all right, so can everyone hear me in the back? We're good? So welcome back to the final demo of the semester. It is very sad to be wrapping up the semester like this, but for those of you who weren't at lecture on Monday, the starter code that's completed from Monday is on the textbook, so you can go ahead and download that. And I guess while we wait for people to do that, we can just quickly go over what we covered on Monday. So how do we store images in a database, right? Firstly, we want the front end to be able to send the image to the backend. The way that happens is through a base 64 string, which is an encoded version of the image, converted into a string. And the reason why we do that is because if we are sending images kind of raw by itself, it's going to be converted into binary data or blobs. And that's not very easy for the computer to understand. So instead, we send it as a long string that kind of has everything about the information encoded within it. So that's what this looks like. And the way we store images in the backend is instead of storing them as actual images themselves, we store the image in a separate service called AWS, Amazon Web Services, and we store the link to those images in our database. Right, so last time we also set up an AWS account. Right, for those of you who weren't here on Monday, we're probably not going to have time for you to kind of set this up, but as long as you follow along in the code and understand what's happening, that should be plenty. So the thing we did in AWS is we created a bucket. And a bucket is basically just a place for us to be able to have all of our images stored. So in demo 8 bucket, you can see that I have a bunch of images stored here. And our database is going to contain links to these images to be able to return to the front end. So that's bucket. And we also set up a set of credentials. So the only reason why we need to do this, why we have to set up credentials, is because if you don't do this, then everyone on the internet can access our bucket and store images on our app, right, which we don't want. So for layer security, we have access keys, which is, you can essentially think of it as a password. And we pass in these access keys to be able to access our bucket. I actually deleted the access key that I created last time in case, like someone on the internet goes to our app.py YouTube channel for whatever reason and tries to use my access keys. But the crux of it is that you have to keep these secure. You do not want to share this key with anyone. You can think of it as a password once again. So to recap how we do that, right? This. We have an environment variable file, the .env file, and in the .env file, we store the access key and the secret access key. So this way, our access key and our secret access key aren't actually exposed in our code, and that way it stays secure and just within this env file, which we don't upload to the internet once again. So then we added in the dockerignore file, the .env, the virtual environment, because we don't want to be pushing that, the PyCache, and our database file. All right, so that was a recap of last time. Oh, actually, yeah, we can go over what we did in db.py as well. So in db.py, we created a new model called asset. And this asset basically is, each asset is an entity that represents the image that we upload to the internet. So it has a base URL, which is the URL to our AWS account. It has a salt, which is the name of the file, extension, which is what file type it is. So, right, we said we accepted PNG, GIF or GIF, JPG, and JPEG files. And width, which is the width of our image, height, which is the height of our image, and created at, which is basically just the date and the time that we created this image. So this is a model that we created. And when we initialize this model, we want to create the image as an entity. So the way we do that is, you can just read through the documentation here, but given an image in base64 form, we reject the image if it's not a supported file type. So if it's not one of PNG, GIF, JPG, or JPEG, we reject it. If it wasn't rejected, also this was supported, sorry. And if it wasn't rejected, then we create a random string for the image file name. The reason why we do that is because we don't want to be storing any sort of user data within the image file names. And then finally, we decode the image from a base64 string back into an image and try to upload it to AWS. All right, so that's what all this code does. And there's comments here along the way to help you out if you aren't sure what each of these things are doing. So are there any questions for what we covered on Monday before we move on? Does that make sense? Okay, cool. So the function we haven't yet implemented on Monday is this upload function. So let's go ahead and create a new function called upload. Right, we take in the self, we take in the image entity as it's as specified up here, and then the file name. And this function will attempt to upload the image to the specified S3 bucket. Okay. So the S3 bucket is specified up here. And we read from our environment variable file instead of actually storing them as a raw string, because we don't need anyone on the internet actually knowing the name of our bucket. All right, so let's implement this function. So we'll wrap it with another try catch in case something goes wrong in the uploading, which isn't entirely our fault, right? So we want to be doing a try catch just kind of as a fail proof in case AWS goes down or something. We don't want our entire app to crash. So, okay, let me move this lower. All right, okay. So first, the way we actually upload it to AWS is we need a reference to where the image is. We need the image to be somewhere on our computer. So we actually temporarily store it in our computers and then upload that to AWS and then delete the image after we've done that. So we will first, am I getting a call from the previous semester course instructor? So first we will save the image temporarily on our server, right? The way we do that is by first specifying a location for our image. So let's call it image temp lock for temp location, temporary location. And we'll make it an F string with starting with the base directory, which we specified up here for those of you who weren't here. It's just how to get there. And then the file name, which we pass in as part of the function. Once we do that, we will img.save, which saves the image in the specified location, right? Which is just stored in this variable as a string. Then we will upload the image to S3. So S3 again is a bucket service that AWS provides us. We want to be uploading our image so that it does indeed get stored in these buckets, right? So the way we upload the image to S3 is by first making an S3 client. And then we want to call a function that's been implemented for us called upload file. So we will upload the file located at this image temporary location at the bucket name that we specified up at the top of our code. And we want to be calling it the image, the file name that is passed into us in upload. All right. So now that we've uploaded the image to S3, we want to make it so that image URL is public. So by default, you're not going to be able to access the image that's in the bucket, but we can change this by changing the permission of this resource that we uploaded. So boto3.resource, the S3 bucket. And this is just a function for changing the permissions of the resource. So S3. Oh, oops, sorry about that. Oh, sorry, I can't spell. Thank you for the correction. Okay, hopefully you didn't copy down my misspelled words. And yeah, we will be changing the permission of the file name specified here. And we can do that by calling object acl.put acl equals public read. So this makes it publicly accessible. Did I spell anything else wrong? Okay, that is good. All right, so we saved the image temporarily in our server, we upload the image to S3, and we make the image URL public. So now that we've done that, we want to be deleting the image from our server, right? We only temporarily saved it because we wanted a reference of where the image is. But now that we've actually uploaded it, we don't need the image on our server anymore, right? The whole lecture on Monday was that we don't want to be storing images on our servers because then they're tied to a specific server and that causes a lot of issues. So we will remove the image from the server by calling os.remove and the location of the image that we're trying to remove. Okay. All right. Are there any questions? Does that make sense? All right. So now that that's done, we will print an exception or print an error if an exception is caught. So earlier we called it error when creating message. So this time maybe we call it error when uploading image, and then we pass in the error that we've caught. So this way, if an error actually does occur, this print statement will be very, very handy for us to debug because it'll tell us specifically what the type of the error is and a few more details regarding it. Right. So this is actually all we have to implement in db.py, right? We have an image model called asset, which when we initialize, we create the image, and creating the image kind of does all this handling of what the extension is, what the file name is, what the image URL is, blah, blah, blah. And then we call the upload function, which then uploads it to AWS. So now all we have to do is go to our db.py, or sorry, app.py, and in our upload endpoint, we want to be calling the methods that we just implemented in db.py. So we will first get the request body by doing json.loads request.data. And then we will get the image data field by doing body.get image data. And if image data is none, right, then the image data wasn't passed in. Therefore, we can return a failure response saying no base 64 image. Cool. And assuming that the image data isn't none, then we've actually successfully received an image data in the request body. So we can then create a new asset object. Meaning asset equals asset image data equals image data. So this is utilizing quirks that we covered in lecture 4. This asset class that we have in db.py, we haven't actually imported yet. So we first have to do that before this actually starts working. So we go to the top of the file, and from db, we'll import the asset class that we implemented. Okay, so once that's done, we will then db.session.add the asset and db.session.commit. So this should be very familiar to all of you as well. And then we will return the successful response saying that, actually, we're not saying anything, but we will serialize the asset and create a return with a response of 201 because we newly created an image. So we haven't actually implemented the serialize function yet. So once that's done, let's go ahead and go to db.py. Are people still copying? Can I move on or? Okay, so if you're not done copying, actually I can just split screen this and just have that there. Let's go to db.py and we will create a new function called serialize. So maybe we'll put it below our init function because that's what we traditionally do. And we've done since BA4. So we will serialize the object. Serializes an asset object. And we can just return a dictionary containing our URL. So this is going to be an F string with the base URL, which is the AWS URL. The salt, so that's the name of our file, and then the extension. I'm assuming everyone copied app.py already. So this is our URL. So this is going to look something like AWS, the link of AWS / the name of our file, image dot, and then the extension, which is like PNG, for example. Okay, so that's one of the fields we want to be returning, and the other one is when it was created. So this we can just do, cast it into a string and return the field created at, which is a datetime object. Right. So hopefully that makes sense. With that out of the way, we can actually test this locally. So the env file that we have here, we specified the bucket name to be images demo shungo. And that's going to be not this bucket, which is the one I was showing for demonstration purposes before lecture, but this bucket right here. So right now we have nothing in it, right? So let's specify in our Docker compose file that our env file that we're going to be using is the one that's called .env. We call this demo 8. This one also demo 8. And then once that is done, we can go to our terminal, and we can build a Docker image. So we'll do docker build -t, username on Docker and demo 8, and we'll build from the current directory. Okay, and let's create a Postman request. called upload image. Maybe we'll just say local, right? And instead of server URL, we can maybe call this local URL and make a global variable called local URL and give it the value of localhost 5000. Cool. So yeah, now that we've built the Docker image, we can Docker compose up-d, right? We specified the image name that we're going to be using. So the image name has to match whatever you built it as down here. And so we can do that. Cool. So now the container is running. We can check that with Docker PS, right? This is very similar to lecture/demo 5. And with the Docker container running, we can hit this endpoint in our Postman. So the body, this image, like really long image data string, was actually used base64-image.d. This is a site that you can use to convert any image to base64 strings. So just to quickly demonstrate what I did in Monday, I have an image of me playing baseball when I was like in 3rd grade, and I can just drag it here. And I'll encode it, and then I can just copy this image as a base64 string. And we can just paste this right here in the image data thing. All right, so with that done, we can go ahead and try sending it. And you can see that I was given a URL and when it was created. So this URL, if we click on it right here and paste it to our browser. Oh, oops. It's recording, right? Yeah. Okay. So you can go back to the part where I set up the bucket. In case you missed it, that was where I made the error in demo. So make sure you set up the bucket correctly, like I do earlier in this video. But once the bucket is set up correctly, this is the expected behavior. Okay, once I've opened my Postman, I can Docker compose. And wait for this to boot up. And once that's done, I can hit the upload endpoint. And you can see that I was given a URL, which if I go ahead and go to the browser and paste, the image will successfully download. And if I go back to my bucket, you can see that the image was successfully stored in my bucket. So yeah, sorry about the hiccup. Make sure you just go back to me setting up the bucket to set it up correctly. Yeah, I'll make a quick re-recording on fixing this once again. But before that's basically it for images. You can see that it correctly was able to upload it to the bucket. All we need to do is fix some part of the URL so that I can actually go ahead and download this. But that shouldn't be too hard of a fix for Hack Challenge. I just wanted to quickly iterate how to deploy this, right? Because deploying this is going to be important. So to do that, we have to go back to Google Cloud. And I'm going to make a new instance. You're probably going to have one instance for your app. But just to reiterate how to do this, I'll show you how. So let's call this image demo Shango once again, and VM. And we can choose a region. We'll choose Toronto. Wait, was it Toronto, Montreal? I don't remember. But you can do that. Maybe we don't need this much computing power, so we can just change to small. And we will change this to be running Ubuntu. And then we can allow HTTP traffic. And then also a really nice thing about Google Cloud is that it tells you like how much your monthly cost is probably going to be. So if you decide that after, say, taking this Intro to Backend course that you want to keep running your app and working on it, you can see your monthly estimate up here. And a lot of the time you can get funding from Google Cloud if you partake in hackathons and stuff like that. So yeah, that's pretty cool. So you can create this virtual machine. And then while we wait for that to boot up, we can go to Docker Hub. And we can see the image that I uploaded here. in our repositories. So, oh, I have to do that. So let's Docker push the demo image that I created. And right, so this new one was created. I called it this one. And you can see that this demo 8 image had a new update. Oops. A few seconds ago, right? This is right here. Right. So this was successfully pushed. Now to actually have this running on our server, we have to pull it, and I'm just gonna SSH to the server that was working. All right. We have to recall how we set this all up. So that includes creating the env file, creating the Docker Compose file, changing the port mapping, and so on. So that was a lot of things to cover since are in demo 6. So we'll just recap what we did. So this is actually a server that's already working, but right, we can vim docker. Let me make this bigger. That's a bit too big. We can vim docker compose.yaml to specify how to build the image. And you can see right here that is basically exactly the same as what we had locally. We specify an env file, we specify which image to use, and what port mapping to use. So 5000 is the port of our app, right, which is the port of our container, and that's why it's 5000. And 80 is the default port for HTTP traffic, which is why it's 80. And we have to specify that we want to be reading from the env file .env. And then we can ls and see that we also have a .env file right here. So let's look into that, and you can see the bucket names right here, the access key is right here, and the secret access key is also right here, which is going to be identical to the one on your local computer. But you have to remember to set these up, otherwise it's not going to work, because again, the .env file is never going to be uploaded to the internet, hence the dockerignore file specifying that we don't want to be actually pushing this. So with the .env file and the Docker Compose file on our server's computer, we can just Docker pull the repository that we created on our computer, and then we can just Docker Compose up, right? And once we do Docker Compose up, we have a running container. And once that container is up, we can finally hit this external IP. And see that this server is in fact running. So this is a quick recap of the deployment demo. Right, so you have to do the Docker pulling, the Docker composing, and all that for this to work. And with that working, we can use this URL instead. And if we hit the upload endpoint, I'm given another URL, which hopefully, I think this one works. Right, if we hit, we can download a file, and it's the exact same file. And this is going to be present in our Docker or in our AWS bucket. And the way the front end is going to interact with this is that the front end is going to send a request with the image URL or with the encoded image. Then you're going to upload it to AWS, return the image URL to the front end, and then the front end kind of just downloads that like I just did on my browser. All right, so that was a lot, but that was actually it for the images demo. Yeah, does anyone have any questions on how any of this works before we move on to the Kahoots and give away the Kahoot prizes for this semester? You good? Awesome. All right, let's move on to the Kahoot. So